In this video, we will be looking at the life and death of a star. So, it turns out that stars come from quite humble beginnings. In fact, they're just a load of space dust and gas grouped together, and that's called our nebula. And gravity pulls all of this dust and gas together to form a protostar. And as all these particles are smashing into each other and the star is getting denser, the temperature increases. And at a high enough temperature, you get hydrogen nuclei fusing together to form helium nuclei. Check out our video on nuclear fusion for this process in more detail. Turns out this process releases a huge amount of energy. The next stage for our star is the main sequence star. And this is the stage that our star is in at the minute. It is a long period and it is a stable period. Well, that makes one of us. So you need to know, why is it stable? Well, the thermal expansion coming from this energy which is released in these fusion reactions, which pushes outwards on the star, is balanced by the gravitational attraction which pulls inwards on the star. And these two forces remain balanced for several billions of years. So luckily for us, the sun's still got a long while to go, chilling in this stable main sequence form. So what happens after this? Well, turns out that hydrogen lets us down. There's not enough of it left in the core. Fusion reaction dies out. That was providing our thermal expansion. Gravity wins and the star gets compressed. But as the star gets compressed, it gets hotter. It gets hot enough that some hydrogen that is in the outer layers of the sun begin to undergo fusion. And actually, some helium that is now in the core of our sun also undergoes fusion. So this release of energy increases that thermal expansion again. And so the outer layers of our star expand, so it is bigger and it is cooler, which is why it now appears red. And this is where our story splits. It depends on how massive the star was in the first place as to whether this part of the cycle is a red giant or a red supergiant. Our sun will turn into a red giant, so let's get to the bitter end of its story first. So this red giant is quite unstable and eventually it ejects the outer layers of dust and gas, leaving behind a core. Solid, hot, dense core called a white dwarf. Okay, now let's see what happens to the red supergiants. So these actually start to undergo more fusion, or sticking nuclei together. And this is how I get heavier and heavier elements being made in my star. In fact, all the elements are made in stars, which means that technically you are made from a star, which technically makes you stardust. I mean, practically it might be a different issue, but... And so your red supergiant undergoes this expansion and then contraction, expansion, contraction, until at some point it's all a bit too much and it explodes. And that explosion is called a supernova. And a champagne supernova in the sky. So what happens after my supernova? Well, again, my story splits into two. The less heavy stars leave behind the core called a neutron star. This is very, very dense. In fact, a teaspoon of a neutron star has the same mass as 900 times the mass of the pyramids of Giza. And if your star was heavy enough, it will leave behind a black hole. This is a super, super dense point in space, and nothing can escape the black hole, not even light. That sounds like the strapline to a rubbish horror film. Okay, hope you found that helpful. Please download the notes with all the diagrams. If you like the video, give us a like and subscribe. Thanks for watching.